Welcome back. In the last section of this lecture, we're going to be looking at finding exact values for our trig functions for angles that are multiples of 30 and 45 and 60. And so we just need to get a few things set up first before we can get there. And one of the things that we'll need to know is what do we mean when we talk about the reference angle for an angle? So if we're talking about any angle that's not a multiple of 90, then we can talk about the reference angle, and the reference angle being how far away is that terminal side from the x-axis. Our reference angle is always measured against the x-axis, never against the y-axis. And our reference angle is always a positive number. So whether we're talking about an angle that's above the x-axis or an angle that's below the x-axis, it doesn't really matter to us. It's always just a question of how far away from the x-axis are we. So for both of these angles, 150 degrees and 210, they both have the same reference angle because both of them are 30 degrees away from the x-axis. So the x-axis is 180 degrees to get to that negative x-axis, and 150 degrees is 30 degrees away. And same thing with 210. It's 180 degrees to get to the negative x-axis and another 30 degrees to get to 210. So the reference angle for 210 degrees is also 30. So we're never going to have a negative reference angle. You're also never going to have a reference angle bigger than 90 because you're always going to be 90 degrees or less away from the x-axis. So when we're looking for our reference angle, all we need to do is just draw our angle and see how far away from the x-axis are we. So let's do some of these. And the ones that are in terms of degrees are probably the easier ones for us to think about because we're used to thinking about degrees. 135 degrees, so 90 degrees would be up at the top and 180 degrees would be at the negative x-axis. So 135 is going to be somewhere in quadrant 2. And if I'm thinking about it being 135 degrees to get to here and 180 to get to the negative x-axis, then my reference angle is just the difference between 180 and 135, which happens to be 45 degrees. So my reference angle is 45 degrees. Of course, if I'm given an angle in terms of radians, then I should really state my reference angle in terms of radians. So for this one, pi over 4, you may have to, on the side, figure out what it is as an angle in degrees so you know where it lives. So pi over 4 is equivalent to 45 degrees. And we know where 45 degrees would be. It would be in quadrant 1. So there is my angle that I'll say is pi over 4. And our reference angle is just how far are we away from the x-axis. You're 45 degrees away from the x-axis if your angle is 45 degrees. So as it turns out, pi over 4 is its own reference angle. So for the angle pi over 4, you are pi over 4 units away from the x-axis. So your reference angle is pi over 4. All right, I'll draw a negative angle here, negative 170 degrees. So negative 170, that's 170 traveling in a clockwise direction. So starting at 0, negative 90 would be at the bottom, and negative 180 would be over here. So negative 110 should be just a little bit, or sorry, negative 170 rather, should be just a little bit less than negative 180. And if we're thinking about how far are we away from the x-axis, there's a difference of 10 degrees between the negative 180 and the negative 170. So it doesn't matter the fact that this angle happens to be negative. My reference angle, regardless of that, is going to be a positive value, and it's 10 degrees because that's how far away from the x-axis we are at that terminal side. So even though my angle happens to be negative, my reference angle will still be positive. For the last one here at the bottom, 7 pi over 6, I mean, you certainly could, if you wanted to, think about what this is in terms of degrees first to help you out. So you could say, great, 7 pi over 6 is equivalent to 210 degrees, and you could draw the 210 degrees and all the rest. The problem's going to come up with, once you've drawn that and found your reference angle in terms of degrees, you're still going to have to go backwards. Since my angle really is in terms of radians, I want my reference angle to be in terms of radians too. So if you do the business of converting to degrees to find out what is 7 pi over 6, then you're going to have to undo that conversion to figure out what your reference angle is. Now, the nice thing is, you don't actually have to go from degrees to radians or radians to degrees if we're just thinking in terms of what we already know. And one thing that we know is that 180 degrees is the same thing as pi radians. So we know that pi radians should be over here at the negative side of the x-axis. Got a little ahead of myself because I was going to say now pi is the same thing as 6 pi over 6. That's for sure true, right? That's just me making an equivalent fraction. Pi is the same thing as 6 pi over 6. And you might say, well, how does that help us? Well, we're looking for 7 pi over 6. And if you're thinking in terms of 6 pi over 6 takes us all the way to the negative x-axis, then 7 pi over 6 should take us just a little bit further. So 7 pi over 6 should be just a little bit past 6 pi over 6. And I can also figure out what my reference angle is without even having to do any conversion back and forth. Since it's 6 pi over 6's to get to the x-axis, and it's 7 pi over 6 to get to my terminal side, then the difference between the 6 pi over 6 and the 7 pi over 6 is a difference of 1 pi over 6. So as it turns out, my reference angle should just be pi over 6. Of course, you'll get the same answer if you converted 7 pi over 6 into 210 degrees, drew 210 degrees, and said your reference angle was 30 degrees, and then converted backwards from 30 degrees into pi over 6 radians. But I think this is actually the better way for us, because we really don't need to care what is pi over 6 or 7 pi over 6 or any other angle in terms of degrees. Since we know where 6 pi over 6 is, we could use that to figure out what 7 pi over 6 should look like. All right, so the other thing that we need before we can find any angle we'd like that's a multiple of 30 or 45 or 60, we need to now find, for 30, 45, and 60 themselves, how do we find their exact values? We've got two special triangles here. One triangle, the 30, 60, 90 triangle, and another triangle, the 45, 45, 90 triangle. And I can use both of those to find the exact values for any trig function of 30 degrees or 60 degrees or 45 degrees. So something like finding sine of 45 degrees, I would say, well, sine of 45 using my special triangle, the one with the 45 degrees in it. For sine of 45 should be opposite over hypotenuse. And for 45 degrees, the opposite side is 1, and the hypotenuse is root of 2. And of course, you'd have to rationalize your denominator, and so sine of 45 is root 2 over 2. If you want tangent of 30, 30 degrees, that's my special triangle, my 30, 60, 90 triangle. For 30 degrees, the opposite side measures 1, and the adjacent side measures root of 3. And I know for tangent of 30, opposite over adjacent should be 1 over root of 3, which of course, once you rationalize your denominator, gives us root 3 over 3. And for the last one, we want cosine of 60 degrees. So for 60 degrees, the adjacent side measures 1 and the hypotenuse measures 2. And cosine of 60 is adjacent over hypotenuse, or 1 divided by 2, or 1/2. So we can find whatever trig function we'd like for 30, for 60, for 45. And so if we have these special triangles in our mind or have them written down, then it's going to be fairly easy for us to complete the following table. So here I've got my little triangles written down below, and I'm going to fill out things. You might have noticed here that I've already switched things from degrees to radians in my triangle. So I was, instead of having 30 degrees and 60 degrees, I've got pi over 6 and pi over 3. And instead of 45 and 45, I've got pi over 4 and pi over 4. So just to fill in what we know, degrees for pi over 6 is 30 degrees. For pi over 4, that's 45 degrees. And for pi over 3, that's 60 degrees. And then we can fill in the chart as we go. So for this, I'm going to do things a little bit cleverly, and I'm going to point out some ways in which I can make my work a little bit faster here. I'm going to start with the first one, sine of 30 degrees. So sine of pi over 6. Sine is opposite over hypotenuse. And so for sine of pi over 6, that should be 1 divided by 2, which is 1/2. I'm going to, of course, fill in the rest of the table in just a moment, and you could just go directly from definitions of opposites and adjacents and hypotenuses, but I'm going to use some identities to make things go a little faster here. So one thing I know for sure already is, since sine of 30 degrees is 1/2, then I know that cosecant of 30 should be the reciprocal, which is 2 over 1. And of course, if I wanted to simplify that, and I do, 2 over 1 is the same thing as 2. And that's not all. I can go one step further. I can say, wait a minute, 30 degrees and 60 degrees, those are complementary angles. And sine and cosine, those are cofunctions. So one thing that we know, courtesy of the complementary angle theorem, sine of 30 degrees should be the same thing as cosine of 60 degrees. And that's because you have two cofunctions where the angles are both adding up to 90. So since we know that sine of 30 is 1/2, then we know cosine of 60 is 1/2. Oh, and that's not all, because since cosine is equal to 1/2, then you know that secant should be reciprocal of 1/2, which is 2 over 1, or just 2. So you'll notice here, if you're really clever and thinking about using all the identities that you already know, you don't have to just stick directly with definitions to come up with all of our exact trig values. I'm going to continue on now. So if I wanted to think about sine of pi over 4, sine of 45, sine is opposite over hypotenuse. So if I wanted sine of 45 degrees, that's 1 over root of 2, which once we rationalize our denominator, that gives us root 2 over 2. So I know sine of 45 degrees is root 2 over 2. I'm going to do the same sort of thing that I did before, which is, number 1, sine and cosine are cofunctions, and 45 and 45 add up to 90, so you know that sine of 45 and cosine of 45 should be equal to each other. So cosine of 45 degrees should also be root 2 over 2. And you can even go further and say, since you know that sine is root 2 over 2, or in other words, sine started off as 1 divided by root 2, then cosecant should be the reciprocal of this. Cosecant should be root 2 divided by 1, which is just root 2. And similarly, since cosine is 1 over root 2, then secant should be the reciprocal, which is root 2 over 1. And I'm just going to continue on. If we wanted to now do the same sort of work for sine of 60 degrees, looking at sine of 60 degrees, you would say for 60, which is pi over 3, sine is opposite over hypotenuse, root 3 divided by 2. And same thing as before, sine of 60 and cosine of 30 would have to be equal by the complementary angle theorem. So cosine of 30 degrees should also be root 3 over 2. And of course I can use my reciprocal properties to clean up the values for secant of 30 degrees and cosecant of 60. I know, since we were talking about 60 degrees, that sine is root 3 over 2. So for cosecant of 60 degrees, it should be the reciprocal of that, which is 2 over root 3, which, when you simplify it, gives you 2 root 3 over 3. And similarly, since we know what cosine of 30 is, then you also know what secant of 30 is, and it's the reciprocal of that, which is also 2 root 3 over 3. So we've actually filled in most of our chart, and I only actually needed to use the special triangles 3 times so far. I just needed to use it to find sine of 30, sine of 45, and sine of 60. The rest of the chart I filled in using complementary angle theorem and my reciprocal properties. So last thing to do is to fill in tangent and cotangent, and I'm going to be doing these as pairs, of course, because tangent and cotangent are reciprocals. They're also cofunctions, so I can use the complementary angle theorem here too. So let's start with tangent of 30 degrees, tangent of pi over 6. Tangent should be opposite over adjacent, which is 1 over root 3. So we know tangent of 30 degrees is 1 over root 3, which, when we rationalize our denominator, gives us root 3 over 3. All right, so far so good. You can also say, since you know that tangent and cotangent are cofunctions, you can say that tangent of 30 and cotangent of 60, that they should be equal to each other. So cotangent of 60 should also be root 3 over 3. So I found the value for tangent of 30 using my triangle and used complementary angle theorem to find cotangent of 60. I also have 2 other things I can still fill in just using the one value that I found. I know that tangent of 30 is 1 over root 3, and so cotangent of 30 should be the reciprocal, which is root 3 over 1, or in other words, just root 3. Oh, but wait, there's one more. Again, using the complementary angle theorem, we know what cotangent of 30 degrees is, and that should be the same thing as tangent of 60. Tangent of 60 should be the same thing as cotangent of 30, and that should both be root 3. So there's only one last thing to fill in, which is tangent of 45, and then from that we'll figure out cotangent of 45. And for this one, we just have to use, again, our special triangles and say tangent of 45 should be opposite over adjacent, or 1 divided by 1, which is just 1. And of course, cotangent is the reciprocal of tangent. Since tangent is 1, cotangent is reciprocal of 1, which is also 1. So there we go. We filled in our table. We found all of our exact values. And again, using some identities, we were able to sort of speed our way through the table. And now we're going to use these values for 30, 45, and 60 to help us find the exact values for any trig function where it's a multiple of 30 or 45 or 60. So the idea behind this is that if you have 2 angles, and if the 2 angles have the same reference angle, then one of 2 things happens. Either the trig functions are equal to each other at that angle, or they have the opposite sign. So for example, if we're thinking about the angle of 30 degrees, and if we're thinking about the angle of 150 degrees, which also has reference angle of 30, then I can say, for example, for sine, either sine of 30 is equal to sine of 150, or sine of 30 and sine of 150 will just be opposites of each other. One is positive, one is negative, but with the same number. And of course, whether they're the same sign or whether they're opposite in sign will depend on what quadrant we're in. So the big plan here is, if you were interested in finding sine of 150, you'd first draw the angle and think about your reference angle, which is 30 degrees, and ask yourself, what is sine of 30? Once you know what sine of 30 is, either sine 150 is equal to it, or it's negative of whatever sine of 30 is. And to figure that out, we would just have to think about what quadrant our angle is in and whether sine happens to be positive or negative in that quadrant. So it's a little bit more involved than what we've already done, but really it's just putting together two things, our special triangles together with our reference angles and quadrants. So let's start with the first one, the sine of 150 degrees. First thing I do, of course, is to draw my 150 degrees, and 150 degrees is over here in quadrant 2. And we know since it's 180 degrees to get to the x-axis that my reference angle should be 30 degrees. So first thing I need to do is figure out what is sine of 30 degrees. And for that, I just need to look at my special triangle and say for 30 degrees, for pi over 6, sine is opposite over hypotenuse, which is 1 divided by 2. So sine of 30 is a half. So that means that for the question that we're interested in, sine of 150, the answer is either going to be positive 1/2 or it's going to be negative 1/2, and we just need to decide which is which. And for that, this is where we think back to our quadrants. We're looking at an angle that happens to be in quadrant 2, and in quadrant 2, sine happens to be positive. So that means that sine of 150 degrees should be positive a half, not negative a half. And that's all that we're going to have to do to find the exact value for any trig function. We draw our angle, find our reference angle, find the value of the trig function for that reference angle, then we go and think about our quadrant. And based on our quadrant, we'll decide whether we just have the answer as is or whether the answer needs to be made negative. In this case, we were in a quadrant where sine is positive, so sine of 150 and sine of 30 are both equal to each other. They're both equal to a half. All right, let's do another one, cosine of 3 pi over 4. This is one where you could, again, convert back and forth from radians to degrees, but I'm going to start doing this without converting back and forth from radians and degrees, because my special triangles here are already in terms of radians, so I should just keep this in terms of radians and it'll actually be a little bit faster for me. Of course, that means we need to first think about drawing 3 pi over 4, but I'm going to do the same technique that I did before, where I know that pi is over here on the negative side of the x-axis. And since we're looking at 3 pi over 4, I'll say to myself, well, pi is the same thing as 4 pi over 4. So since it's 4 pi over 4 to get all the way to the x-axis, 3 pi over 4 should be a little bit less than that. And if we're thinking about how far away am I from the x-axis, I'd say, well, since my angle 3 pi over 4 takes me all the way to here, and it's 4 pi over 4 to get all the way to the x-axis, the difference between 3 pi over 4s and 4 pi over 4s is 1 pi over 4 of a difference. So it looks like my reference angle is pi over 4. So I'll start off with first finding what is, in this case, cosine of pi over 4. And using my special triangle, cosine is adjacent over hypotenuse, 1 divided by root of 2, which of course we're going to need to rationalize that denominator. So root 2 over 2, there we go, that's cosine of pi over 4. And now we need to think about our quadrants. We need to think about, we are in quadrant 2, and in quadrant 2, that's where sine happens to be positive. So we know that cosine of 3 pi over 4 happens to be then negative. So that means cosine of 3 pi over 4 shouldn't be positive root 2 over 2. It should be negative root 2 over 2. And there we go. We found our exact value for cosine of 3 pi over 4. All right, one more to look at. Cosine of 330 degrees. So drawing our angle, a full circle is 360 degrees, so 330 should be a little bit before that. There's 330 degrees. And it's 360 for a full circle, and we've drawn 330, and so the difference between the two is a difference of 30 degrees. So there we go. There's our reference angle. I need to first start by finding cosine of 30 degrees. So pi over 6, or 30 degrees. Cosine is adjacent over hypotenuse, or root 3 over 2. And then next, thinking about our quadrant, the angle that we're looking at happens to be in quadrant 4, and in quadrant 4, cosine is positive, so we know cosine of 330 should be positive, so therefore cosine of 330 degrees is positive root 3 over 2. All right, another one in radians. So again, if you wanted to convert it to degrees, you can, but I think it's nicer and faster if we keep it in terms of radians throughout. So I'm drawing my angle. We're looking for 4 pi over 3, so pi lives over here. If I'm thinking about it, that pi is the same thing as 3 pi over 3. And so it's 3 pi over 3 to get to the x-axis, so 4 pi over 3 should be a little bit past it. And if we're thinking about how far of a difference there is, it's 3 pi over 3 to get to the x-axis and 4 pi over 3 to get to the terminal side. So the difference between 4 pi over 3 and 3 pi over 3 is 1 pi over 3. So it looks like my reference angle is just pi over 3. So let's find our sine of our reference angle. Sine of pi over 3. And looking at our special triangle, sine is opposite over hypotenuse. So for pi over 3, opposite is root of 3, and hypotenuse is 2. So root of 3 over 2. And there we go. We found our value for sine of pi over 3, and now we're ready to find out for 4 pi over 3, is sine going to be positive or negative? So our angle here, 4 pi over 3, happens to be in quadrant 3. And in quadrant 3, it's tangent and also cotangent that happens to be positive. So we know that sine is negative. So we know for sine of 4 pi over 3, it's going to be negative. That means sine of 4 pi over 3 should be negative root 3 over 2.